I wanted to give you guys a couple hints for the assignment that I'm going to still accept late. Don't worry about, you won't get penalized for being late. So I'm giving you this one here because it will help you go through the whole thing with exercise 1. So again, when you go back to the geometric series, right, it's going to look like something like this, where you have a first term and then you have r to the nth power, meaning you're just going to have like a plus ar plus ar squared plus dot 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 and so on. Now, power series is pretty much the same, but instead of having the r, they use x, but n still goes from 0 to infinity. The first term, now they use c sub n, all right, and then you have x to the nth power. So this is considered a power series, which is basically the same thing: c sub 0 plus c sub 1 x plus c sub 2 x squared plus c sub 3 x cubed plus dot 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 plus c sub n x to the n, and then it continues on forever. Now, when we talked about convergence for a geometric, it was between -1 and 1, or r, the absolute value of r had to be less than 1. If it diverges, right, you knew that absolute value of r was going to be greater than or equal to 1. And this works the same way with the power series. So in order for something to converge, and they call it the interval of convergence, is that absolute value of x needs to be between 1 and -1, okay? So now let's get to, and one other thing. When you're looking at the geometric sequence, okay, we know that the sum is always going to equal, as long as r is less than 1, we know our sum will be a, first term, over 1 minus r. So in this situation, it's going to be the same thing. You're looking to get, when you're talking about interval of convergence, we're going back to this formula to help us get functions. So when I look at this, I know what my first term is, and I know what my radius of convergence is, or I could get my interval of convergence, sorry, but I know what my common ratio is. So let's do this problem here. So it was 2x, right, 2x over 1 plus 4x, okay? So right away, you know your first term, okay? So first term is always a, right? And so in our situation, it would be 2x. Our common ratio, now what I'm going to do, because it's not 1 minus, just put the minus outside and do -4x like that. That means that's our common ratio. So we know that our power series for this is going to be our first term, right? And then what you want to do is just multiply everything by the common ratio. So you have minus 8x squared, right? And then plus, right, multiply by another -4x. Okay, so that'll give me a positive 32x cubed, and then minus, and multiply it by 4x again. Okay, and you'll get, what is that going to come out to? Minus 128x to the fourth plus dot 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 plus. Now, if you have to come up with, a common look of it, right? Well, if you know your first term is going to be 2x, okay, and you could see that we're just multiplying by 4 every time, you could have the 2 out in front, x to the n, and you want to say plus 1 power. I mean, that should, I forgot the 4. Okay, so it would be plus 2, and then you would have 4. You want to make sure you have a negative because it alternates. All right, because of that negative, it's going to be -4x to the n plus 1. Okay, and actually I don't like how that looks because that first term so let's do it this way. Now always, if you notice, I like hesitated there because I wanted to check my term. Like here I don't want that -4 to be used right away, okay, but the x I do want it to have an n plus 1 because my first term has an x. So this would be our general form of the power series, okay? So right there, that's how you can get the series. So when you're looking at example 1, right, just think of what's my first term and what am I multiplying each additional term by, and that's how you could get the power series, and then kind of use that to your advantage to get the general form. Now, interval of convergence. All right, let's go back to, right, if you look at the top, let's go back to this for our power series. So what my ratio is going to be, right, so in this situation, I want that -4x, right, to be less than 1. Now, because it's absolute value, the -4 goes away, and it's just 4x has to be between -1 and +1. All right, so if you divide both sides by, or all sides by 4, you have your interval of convergence to be -1/4 to +1/4, meaning that as long as you're picking numbers, right, so the way we would write it as interval notation, as long as you're picking numbers between -4, -1/4, and 1/4, then this series will converge, okay? So that should help you out with example, or exercise 1, I should say. Now, exercise 2, you got to work out it a little bit, okay? But I'll give you a hint. You're going to have to use an integral somewhere, all right? Think about what is the integral of tan inverse x, and then go from there. You could do the power series that is given to you in number 1 plus x squared, and I think once you do exercise 1, you'll be able to get that portion of it, okay? But what I want to show you what to do is number 1, how do you take an integral of a power series? Okay, so again, if you're looking at this, right, this, just to go over a couple things, right, let's talk about rewriting it this way. Okay, so again, let's just, in general, our first term, plug in 0, right? So you just have 2x to the 0 power, which is 1. So that's our first term. Our ratio here is going to be 2x because that's the one where the power is being, raised to the n. So meaning you're multiplying everything by this. So what this is going to look like is your first term is 1 plus 2x plus 4x squared plus 8x cubed plus 16x to the 4th plus ... plus the 2x to the n power and plus ... So that's what that's going to look like. If we're looking for our interval of convergence, again, you're just taking that common ratio and making sure it's between -1 and 1. So in our case, we want x to be between -1/2 and +1/2. Or you could write it in an interval notation this way. Okay, but what I didn't do yet was how do we do the integral of this whole thing, right? So what I want to do is, let's take this, move it down. Let's take this, move it down, okay? And we are going to now, right? So if this is our function, right, that we're looking at, right? Oh, again, let me just show you something real quick. You could write this as a function, right? F of x is going to equal our first term over 1 minus that common ratio, 2x. So this is what our function looks like, right? What we want to do is take the integral of that function, okay? So I have room on this side. Yeah, let's move this whole thing. All right, cool. So let's take the integral of this whole thing. Now, what I want to do, I'm going to do this up here. I want to do the integral from 0 to x of f of t dt. All right. Now, this is my f of x. Okay. So what I'm really doing is I'm doing the integral from 0 to x of this function, but I'm putting the t there for just like a dummy variable. All right. And now we know our rules, okay? Just going back to natural log, if you have to, right, review those rules, because this should have a negative 1/2, right? You're doing the reciprocal of that derivative inside, right? And then ln of 1 minus 2t, okay? And I'm gonna not worry about the plus c here, because the main thing now, what I want to do is now, right, I'm doing the integral from 0 to x of this whole function here, 1 plus. Now I'm just changing these to t's, 4t squared plus 8t cubed plus, and you don't have to do every single term, but you want to try to get to this general term. Oh, I don't want the x in there. I want t. And that I also did. Okay, I want to stay consistent. Now, you don't have to do this. This is an extra step, but it's just showing you how we could do this thing and rewrite it. I'm going to rewrite it a little bit. Okay, I like the 1 plus 2t plus 4t squared. Those are easy to take the integrals of. Okay, and 8t cubed, but I want to break this thing up to 2 to the n and then t to the n, and you'll see why in a second. Now, when I do the integral, right, you're doing the same thing. What's your integral of a constant? That would be t, right? This one would be t squared, right? This is going to be 4 cubed over t cubed, right? Plus this will be 2, yeah, you divide it, so 2t to the 4th plus dot 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 plus now 2 to the n. That's constant. Okay, so whatever you're doing to this, that just stays constant because the t is the variable. So it's t to the n plus 1 over n plus 1. Okay, and it looks like that, plus dot dot dot. Now, we are just evaluating, from 0 to x. So really the t portion, I don't mind if I don't see that, but maybe on the AP test they need to see this, okay? And then you're just plugging in everywhere you see a t, you're really just putting the x now. So now you have this function here, and you figured out the power series for negative 1/2 ln 1 minus 2x. So I got a power series for a function by doing the integral of that function that we already knew. Okay, so that's a little hint on what you need to do for exercise 2. Okay, because again, you should know what's the derivative of tan inverse and what is the integral of 1 over 1 plus x squared, which I kind of gave you the answer for that. So think about that. Now, when you get to, letter D, so 2D, I'm giving extra credit. All right, now the last one we have, taking that same function, and what I'm going to do now is I'm going to do the derivative. Okay, so if we go back to the things we had, right, we had a function of x that looked like 1 over 1 minus 2x, okay? I could take the derivative of this function, and I would get a negative 1 minus 2x to the negative 2 times the negative 1/2, right? So I have a function now that negatives cancel, and I have 1 over 2, 1 minus 2x squared. Okay, so that's my derivative. I'll go back to that in a second, but when we go back to the terms we had that represented this function, right, f of x, we wrote them down as our first term was 1, and then we had plus 2x plus 4x squared plus 8x cubed plus dot 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 plus, and then I had it written this way to help us with integral. So let's keep it the same thing. If you're doing a derivative, just do each term separately, right? So you'll get 0 plus 2 plus 8x plus 24x squared plus dot 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 plus 2 to the n times nx to the n minus 1 plus dot dot dot. Okay, and that's really it. So when you're getting to number 3, okay, if they ask you for the derivative, you are just taking the derivative of every single one of those terms, okay, and trying to simplify it from there. Now I'm not giving you all the answers, but that's really all you have to do for that power series, okay? And then secondly, if you're doing just f of 0, right, you are plugging in zeros everywhere you have an x. So in our situation, in this one that I'm doing, f of 0 is just going to be 1. That should be pretty similar to the problem you guys have for exercise 3, letter B. Okay, then take a look. Does it look like a similar function? When you did this, did anything change? Okay, in our situation, it did change a little bit. All right, you could see the difference in our notation. Okay, so then that should help you to answer letter C. Okay, but for exploration 3, I'm gonna let you do let's see, D, E, F, right? D, E, F, and G will all be extra credit. Okay, hopefully that helps. Another little rule, right? We knew our interval of convergence here was -1/2 to 1/2. Anytime you do a derivative or an integral of power series or geometric series, the interval of convergence always stays the same. Okay, the interval of convergence always stays the same. I hope that helped you guys. I will let you have time to finish that, but please get it done. And if you have any questions, don't hesitate to email. All right, thank you.